Hello and welcome to BrushMyQuant channel. In this video, we are going to talk about how to approach some of the advanced problems on remainders. Before going through this video, I would highly encourage you to go and watch the remainders basic video first. And I've already placed a link of that in the description of this video. In this video, we are going to talk about how to find remainders of numbers when divided by 2, by 3, by 5, by 9 and by 10. Then we'll see how to find remainders of numbers when divided by other numbers. Then we'll talk about what is binomial theorem and how can we leverage binomial theorem in finding remainders. Now let's start by looking at how to find remainders of numbers when divided by 2. So when we are trying to find a remainder of a number by 2, the only thing which we need to know is whether the number is odd or even. If the number is odd, then the remainder will be 1, and if the number is even, then the remainder will be 0. Let's take an example. So the question is, find the remainder when 323 is divided by 2. Now we know 323 is an odd number. So based on this, remainder of 323 when divided by 2 will be 1. Let's try another one. Find the remainder when 424 is divided by 2. Now 424 is an even number. That means when I'm trying to divide 424 by 2, I will get a 0 remainder. Let's try some other problems. So the question is, find the remainder when 3 raised to 84 is divided by 2. Now I know 3 is an odd number, and an odd number raised to any number will always give me an odd number. That means 3 raised to 84 is an odd number. So when I'll try to divide it by 2, I will get 1 as remainder. Let's try the next one. Find the remainder when 12 raised to 83 is divided by 2. I know 12 is an even number, and an even number raised by a number greater than 0, I know it will always give me an even number. That means 12 raised to 83 is an even number, and we know that when we divide an even number by 2, we get 0 as remainder. Now let's see how can we find remainders of numbers when we are dividing them by 3. So when we are dividing a number by 3, then finding the remainder is same as finding the remainder of the sum of the digits of that number by 3. Let's take an example. So let's say I'm trying to divide 123 by 3. What we are saying is the remainder of 123 by 3 is same as finding the remainder of sum of the digits. So 1 plus 2 plus 3 divided by 3, which is nothing but 6 divided by 3. That means 0 remainder. So if you have to find remainder of a number by 3, you just need to find the remainder of sum of the digits by 3, and that will give you the same remainder. Let's try a couple of problems. Let's try the first one. So find the remainder when 31243 is divided by 3. We know that we can just find out the sum of the digits, which is 3 plus 1 plus 2 plus 4 plus 3, and that is nothing but 4 plus 2 6, 6 plus 4 10, 10 plus 3 is 13. So that means 13 divided by 3, which we know that will give me a remainder of 1. That means 31243 when divided by 3 will give us 1 remainder. Let's try the second one. So find the remainder when 45326 is divided by 3. Let's find the sum of the digits. So 4 plus 5 plus 3 plus 2 plus 6, which is nothing but 9, plus 3 12, 12 plus 2 14, and 14 plus 6 is 20. That means 20 divided by 3, which is nothing but 2 remainder. So the remainder of 45326 when divided by 3 will be nothing but. Now let's see how can we find remainders of numbers when divided by 5. So when you're trying to divide a number by 5, the remainder will be same as finding the remainder of the units digit of the number by 5. Let's take an example. So let's take 123 and let's try to divide it by 5. Remainder is same as finding the remainder of the units digit by 5. That means this will give you the same remainder as 3 by 5, which is nothing but 3. Let's try out a couple of problems. Let's try the first one. So find the remainder of 31243 when divided by 5. So 31243 when divided by 5. Let's take the units digit, which is 3. That means this remainder is same as that of 3 by 5, which is nothing but 3. Let's try the second one. In this one, we know that 6 is the units digit. So 6 by 5, which is nothing but 1, will be the remainder. That means 45326 when divided by 5 will give us 1 remainder. Let's try other problems. So find the remainder when 2 raised to 85 is divided by 5. So we need to find 2 raised to 85 divided by 5. Now we know that we need to find the units digit of 2 raised to 85. Now it's not straightforward. So what we need to do is we need to find a pattern of units digit of powers of 2. So let's start by taking 2 raised to 1. We know units digit is 2. 2 square, units digit is 4. 2 cube, units digit is 8. 2 raised to 4, units digit is 6. 2 raised to 5 is 32 and units digit is 2. 2 raised to 6 is 64, so units digit is 4. So as you will notice that the units digit have started repeating. And if you go for 2 raised to 7, that is 128, so units digit is 8. That means the units digit of 2 has a cycle of 4. So it is repeating after every 4 number. What I can do, I can divide 85 by 4 and get the remainder. I know 84 is divisible by 4. So 85 by 4 will give us 1 remainder. That means 2 raised to 85 will have the same units digit as 2 raised to 1, which is nothing but 2. So 2 raised to 85 by 5 will give us the same remainder as 2 by 5, which is nothing but 2. Let's try one more. So find the remainder when 3 raised to 85 is divided by 5. Again, we need to find the units digit of 3 raised to 85. Let's use the cycle method. So 3 raised to 1, units digit is 3. 3 square is 9. 3 cube, units digit is 7. 3 raised to 4, units digit is 1. 3 raised to 5 is 243, so units digit is 3. As you will notice, the digits have started repeating and the next one will be 9. So that means units digit of 3 has a cycle of 4. Again, we are going to divide 85 by 4 to get the remainder as 1. So that gives us 3 raised to 85 by 5 will have the same remainder as 1 by 5, which is nothing but 1. Now let's see how to find remainders of numbers when divided by 9. Now this is very similar to what you have done in case of 3. So to find remainder of a number by 9, it is the same as finding the remainder of sum of the digits by 9. Let's take an example. So let's say the number is 1, 2, 3, 4, 5 and we have to find the remainder of this number by 9. What we are saying is this is same as adding all the digits. So 1 plus 2 plus 3 plus 4 plus 5 and dividing them by 9, which is nothing but 15 divided by 9 or 6. That means 1, 2, 3, 4, 5 when divided by 9 will give us 6 remainder. Let's try out some problems. So the first one, find the remainder when 31243 is divided by 9. Let's add all the digits to have 3 plus 1 plus 2 plus 4 plus 3, which is nothing but 4 plus 2, 6, 10 and 13. So 31243 when divided by 9 will give us the same remainder as 13 by 9, which is nothing but 4. Let's try the second one. So you have to find the remainder when 45326 is divided by 9. Let's add all the digits. So we'll have 4 plus 5 plus 3 plus 2 plus 6, which is nothing but 9 plus 3 12, 12 plus 2 14, and 14 plus 6 is 20. So 20 divided by 9. So 45326 when divided by 9 will give us the same remainder as 20 by 9, which is nothing but 2. Now let's see how can we find remainder of a number when we are dividing them by 10. So when you divide a number by 10, then the remainder is same as the units digit of the number. This is probably the easiest one. So let's try to find remainder of 123 by 10. And what we are saying is the remainder will be same as the units digit of this number, which is nothing but 3. Let's try some examples. So you have to find the remainder when 31243 is divided by 10. And we know that the remainder is same as the units digit, which is nothing but 3. Let's try the second one. Find the remainder when 45326 is divided by 10. We know it is same as the units digit, so our answer will be 6. Now these are probably some of the easier problems. Let's see what happens when we get a number apart from all of these numbers. So let's see how to find remainders of numbers when they are divided by numbers other than what we have seen till now. Let's try this one. So find the remainder of 2 raised to 46 when it is divided by 7. Now we don't have a standard rule for finding remainders by 7. So what we are going to do here is we are going to use the cycle method again. But instead of finding the units digit using the cycle method, we are going to find the remainder of powers of 2 by 7. And we are going to see what is the cycle of that. Let's start by 2 raised to 1. So 2 raised to 1 when divided by 7 will give us 2 remainder. 2 square when divided by 7 becomes 4 by 7 will give us 4 remainder. 2 cube by 7 will give us 8 by 7 will give us 1 remainder. Now notice that whenever you get a 1, then the cycle repeats. That's an indication to you that the cycle is going to repeat, but we are still going to check it further. So 2 raised to 4, which is 16, when divided by 7, will give us 2 remainder. So it has started repeating. 2 raised to 5, which is 32, divided by 7, will give us 4 remainder. So I know the cycle of remainder of power of 2 by 7 is 3. That means I can divide 46 by 3 and check what is the remainder. I know I can find some of the digits, which is 10, and 10 by 3 will give me 1 remainder. That means 46 by 3 is 1. So 2 raised to 46 by 7 will give me the same remainder as 2 raised to 1 by 7, which is nothing but 2. So this is how we are going to solve for remainders of numbers, which are a bit different from what we have seen till now. So we are going to use the cycle method, and that's how we are going to find the remainder. Let's try one more. So find the remainder of 2 raised to 92 when divided by 6. Let's use the cycle method. So 2 raised to 1 divided by 6 is 2 by 6, will give me 2 remainder. 2 square by 6 becomes 4 by 6, so 4 remainder. 2 cube by 6 becomes 8 by 6, so 2 remainder. 2 raised to 4 becomes 16 by 6, which gives me 4 remainder. So we can see that the cycle is 2. So we are going to divide 92 by 2 and check the remainder, which is 0. And we know that a remainder of 0 when we are dividing by 2 is same as a remainder of 2. That means 2 raised to 92 by 6 will give me the same remainder as 2 raised to 2 by 6, which is nothing but 4. Now if you notice, we are able to solve these problems because we are able to leverage the cycle method. This is only because the numbers are smaller. Now what happens if the numbers are bigger? So let's go ahead and learn binomial theorem first, and then we'll see how can we apply that on those bigger number problems. So binomial theorem is used to expand a plus b whole raised to n, which is nothing but nc0 a raised to n b raised to 0 plus nc1 a raised to n minus 1 b raised to 1 and so on, and the last term is ncn a raised to 0 b raised to n. Now each and every term in this has three components. The first component is a combination component, the second one is a power of a, and the third one is a power of b. The top of the combination will always have n, and the bottom of the combination will start with a value of r equal to 0 and will go on till r reaches n. The power of a starts with n, it goes on decreasing till it reaches 0, and the power of a is also equal to the difference between the top of c and the bottom of c. The power of b starts with 0 and it goes on increasing till it reaches n and is always same as the base of c. Now let's try to use this formula and expand. Let's say 10 plus 3 whole raised to 21. So if you compare both of them, your a becomes 10, b is 3 and n is 21. So we'll start with the first term, which will be 21c0 a raised to n, so 10 raised to 21, and b raised to 0, so 3 raised to 0. The second term will be 21c, the bottom of c will start increasing, will become 1. The power of 10 will start decreasing, so 10 raised to 20, and power of 3 will start increasing, so 3 raised to 1. The next term will be 21c2, 10 raised to 19, 3 raised to 2, and so on. The second last term will be 21c20, 10 raised to 1, 3 raised to 20, and the last term will be 21c21, 10 raised to 0, and 3 raised to 21. Now let's try to use this formula to find remainder in one of the problems. So you have to find the remainder when 86 raised to 125 is divided by 17. You might be wondering how exactly are you going to break 86 into two terms. So the idea is to break 86 into two terms such that one term is a multiple of 17 and is very close to 86. So that means I can break it as 85 plus 1, and the other term has to be a very small number. Now let's use binomial theorem and expand this. So this becomes 85 plus 1 whole raised to 125, which is nothing but 125c0, 85 raised to 125, 1 raised to 0, plus 125c1, 85 raised to 124, 1 raised to 1, and so on. Second last term becomes 125c124, 85 raised to 1, 1 raised to 124, and the last term is 125c125, 85 raised to 0, and 1 raised to 125. Now let's see why exactly we did this. So we were trying to find remainder of a number by 17, and we broke down the number into two parts, which is 85 plus 1, such that one part is a multiple of 17 and is very close to 86, and the other part is a very small number. Now if you notice, all of these terms have some power of 85. Only the last term doesn't have any power of 85 because it is 85 raised to 0. So when I'm trying to divide each of these terms by 17, I know I'll get 0 as remainder because they all are multiples of 85. So my question is reduced to what is the remainder when this last term is divided by 17? And if you remember, NCN is equal to 1. That means 125C125 is anyways equal to 1. 85 raised to 0 is equal to 1. And I'm left with 1 raised to 125. So let's try to generalize this. Whenever I have a problem like this, I'm going to break this number into two numbers. One number has to be a multiple of 17 and very close to 86. Another number has to be a very small number. I don't have to go through the hassle of opening the binomial theorem because I know my end result is just going to be this number raised to this power. So that means this question is reduced to what is the remainder when 1 raised to 125 is divided by 17, which is nothing but 1 in this case. So let's try to use this theory in the next problem. So you have to find the remainder when 51 raised to 125 is divided by 7. Let's try to break 51 into two numbers such that one number is a multiple of 7 and very close to 51. So I can break it as 49 plus 2. And using the theory which we have learned in the previous problem, my problem will be reduced to what is the remainder when 2 raised to 125 is divided by 7. Now I don't have a direct answer to this, so I will use the cycle method. So let's try to find the remainder of powers of 2 by 7. So 2 raised to 1 by 7 will give me 2 remainder. 2 square by 7 will give me 4 remainder. 2 cube by 7 will give me 1 remainder. And is going to repeat from now on. So 2 raised to 7, which is 16 by 7 will give me 2 remainder and so on. That means the remainder of power of 2 by 7 has a cycle of 3. So I'm going to divide 125 by 3 and I can find the sum of the digits. So 3 plus 5, 8 and 8 by 3 remainder is 2. That means 2 raised to 125 by 7 is going to give me the same remainder as 2 square by 7, which is nothing but 4. So in this video, I wanted to cover a couple of advanced problems on remainders, how to find remainders of numbers by 2, 3, 5, 9, 10 and other numbers, and then how to leverage binomial theorem in some of those remainder problems. Hope you are able to get your doubts clarified for remainders. If you did, then please go ahead and like the video, provide your valuable comments, subscribe to this channel, and please share this video with your friends. Thank you.